Hello, Year 7. Hope you're all well. Today I'm going to talk to you about circuits and current. I'm just going to talk to you a little bit about it first before I ask you to do this first activity. So, you get particles that carry electric charge, and in these electric wires, these particles are called electrons, and that's what we're going to be looking at today. We're also going to be looking at how electric current is a flow of charge, and in a wire, this can be a flow of electrons. And that's what you need to be able to transfer energy, okay, like in a battery or a power pack. So what I want you to do first is I'd like you to have a go at matching the symbol with its correct name. So I'm going to give you 2 or 3 minutes to have a go at doing this. So whether you want to write it down in front of you or try and do it by looking at my PowerPoint, and then I'll get back to you in 2 minutes. So hopefully you paused the video there so you could have a go at doing that. So I'm going to move on. So hopefully you put the switch is what it looks like on the left. So you can see that this switch is open. You've got a wire which just looks like a straight line, and then you've got a bulb that looks like so, or a lamp, and then you've got your battery or cell at the bottom there. So today we're going to make sure, or hopefully make sure, that we understand how to confidently draw electric circuits. And our key words for today are current, switch, ammeter, amps, cell, battery, and motor. So, as you can see in the diagram below, this is what a circuit actually is like. We're just going to talk about it a little bit to hopefully try and understand what's going on. So, as we look at number 1, it says the bakery manager loads the bread onto the vans and sends them off. So that's a starting point. So we need the bread, we need it to be delivered. So the bakery manager is loading the bread onto that van there. Then at number 2, as soon as the van starts to move, bread is delivered to the supermarket. So we've got from where it starts off, where it's made, it's packed in the lorry or the van, and then it's sent to the supermarkets from where we buy it. At number 3, all the vans move at the same speed. Okay, so there's some travel restrictions in terms of speed. So they can only move at the same speed all the way around the circuit, and that's what's shown here. As you can see inside, it says there's an empty van at the top there, collects the bread at the bakery. Each van takes bread to the supermarket. So they're all taking the same amount of bread at the same speed. The van delivers the bread to the supermarket where the shoppers take it away. The empty vans go back to the bakery to get more bread, and the whole process starts all over again. If the manager speeds the van up, more bread is delivered to the supermarket in a certain time. So obviously, if you think about it, if you're travelling at a faster speed, you're going to be able to get that bread delivered in a quicker time. If the manager loads more bread onto each van, more bread is delivered to the supermarket in a certain time. So it's thinking about speed and the distance and time, basically. Okay. So this battery, okay, provides us energy. So anything we need to light up, to get it to work, if it needs a battery, the battery has the job of providing the energy. The energy is carried by electric charges. The charges are already in the wire. The flow of the charges is an electric current. The energy carried by the charges is given out to the bulb as heat and light. So often energy is wasted as heat. So that's not the very useful energy unless we're using something like a hairdryer that we want the energy from, or a heater to warm us up. We actually don't want that energy. That's often wasted, but we do often want the light. So most appliances, if we plug them in, they give off heat as a wasted form of energy. We don't normally need that. So that's where it's not as efficient. So things like LED light bulbs are more efficient because they provide more light and waste less energy by heat. The charges return to the battery to collect more energy. So this is it again, not using the analogy of the vans, but this time in a circuit. So we'll start at number 1 and have a look at this one now. So the battery provides energy and makes the charges move. So nothing would work in this circuit if we didn't have the battery to provide that energy. So we've got a battery that's working well, it's providing energy, and the charges are moving in that circuit. At number 2, as soon as the charges start to move, the bulb lights. So we know the circuit's complete because the light is coming out of the bulb there. It's a nice lit bulb. At number 3, all the charges move at the same speed. So again, like we said before with the vans, they're all moving at the same speed. Which let's have a little look at the definitions inside there. Charges collect energy at the battery, like we know. Charges are atom-sized, okay? Particles in the wire. The charges carry energy. The charges deliver energy to the bulb where it is transferred to heat and light. The charges return to the battery to collect more energy. So eventually, as it goes around the circuit, the particles will lose that energy and they need to regain some more energy. So they regain that charge at the battery again at the top. If the charges speed up, more energy is delivered to the bulb, as we know already. Same applies. If more energy is carried by each charge, more energy is delivered to the bulb in a certain time. So it's the same as before, we're just looking at it in a circuit this time. Okay, so what I'd like you to have a go at doing is copy and filling in the gaps below from what we just spoke about. So I'm going to give you about 5 minutes to do this, and then I will come back to you. So at this point, you need to pause the video, have a go for 5 minutes, and then come back to me and we'll go over the answers. Okay, so let's have a look at the answers then for the first part, I think. So we'll go back to the second part in a minute. So just 1 to 5. So the bakery is like the battery in the circuit. So hopefully you put battery. So if you've been writing this down, you can tick your work as we go through it. The vans are like the charges in the wire. The bread and the vans are carrying. But that doesn't quite make sense. The bread in the vans are carrying what is like the energy, okay, carried by the charges in the wire. The supermarket is like the bulb. Here the bread is passed on to the customers just like the energy carried by the charge is transferred to heat energy and to light energy in the bulb. So we've got our wasted heat energy and our useful light energy. The empty vans return to the bakery for more bread. This is the same as the charges going back to the battery for more energy. Just going to go back to the previous slide just so you can have a go at 6 and 7. So again, pause the video, have a go at these gaps, and then we'll go over the answers. Okay, so number 6. If the bakery manager speeds up the vans leaving the bakery, bread arrives quicker at the supermarket. Makes sense. This is like the charges arriving more quickly at the bulb in the circuit. Number 7. If the bakery manager loads more bread onto each van, then more bread is delivered to the supermarket in a certain time. This is like more energy being delivered to the bulb in a certain time in the circuit. The chain of moving vans is like a flow of charges. In a circuit, we call this an electric current. So, moving on then. So we've got here a little activity for you to have a go at again to see how much you understand this. So I'm going to give you 5 to 7 minutes, okay? I think that's probably enough time to have a go at this. So let me go through it first. It says the big circuit. So Mr. Harris set up the big circuit in his laboratory. So here you can see the circuit. See if you can try and identify some of the symbols that we've already spoken about. So we've got the bulb there for one and the switch. He measured the currents in 2 places and found current 1 is 1.8 amps and current 2 is 1.8 amps as well. So the current is the same in position A and position 1, and position 2. So Robbie said, that's not right. The current gets used up in the bulb to give heat and light. is Robbie correct? So tell me if you think yes or no. And number 2, explain why you think this is. So you might want to refer to the supermarket picture, so you can go back and have a look at that again if you want to try and give me a few sentences as why you think this is. Okay, so pause the video now. Okay, so what I'd like you to do with this answer is I'd like you to email your science teacher the answer to this. It would be nice to hear your answers. So you could either email me, say Miss Cox, or you could email your own science teacher with the answers to 1 and 2. So I'm not going to go over this now. I'd like to see what you put yourself. Okay, right, let's move on. So let's just go over a little bit of theory then. So when you complete an electric circuit, charged particles move in the electric wires. Okay, we know this. The current is the amount of charge flowing per second. Okay, so the amount of current we've got is the amount of charge flowing per second. When we talk about electricity, we mean an electric current. So at the top here, we've got a picture of a bulb in a torch, and we've got it as a circuit diagram as well. So you can see it in a diagram as in like a torch and what it would look like, okay, if we drew it out in a proper circuit with the correct symbols. So as you can see, when you press the switch on the torch, the light comes on. Okay, so the switch has got to be closed for the circuit to be complete. So the switch opens and closes a gap in the circuit. So as you can see the switch there on the bulb, on the torch, sorry, as you press the switch down, that closes that circuit. So then it's complete and the bulb lights up. Okay, that's how it works. So you need to close the gap for the circuit to work. Otherwise, that flow of charge cannot happen. I've got some links here below if you want to have a go at watching these clips and writing some more information to help you with this topic. Okay, so there's BBC Bite Size here that are good, and there's a couple of YouTube clips as well if you want to have a look at those to help you with this. Maybe write some additional notes to what you've already done, or if you're not sure and there's some things you're not quite understanding, hopefully if you watch some more clips that will help embed what you understand a bit better. So, name the meter you use to measure current. What is the unit for current? So, let's have a look at this here. So we've got the current in this circuit is 0.04 amps. Let's have a little look. So we can see that there. So we've got our battery, we've got our switch, we've got our bulb, okay, and we've got our ammeter there that's measuring it. It's measuring at 0.04 amps. Okay, so this is what is used to measure current. And the unit for current is amps, which is represented by a capital A. So, name the meter you use to measure current. What is the unit for current? Same question. So here's our answer I just explained to you. An ammeter, that's the piece of equipment we put into our circuit if we were doing it in the lab. Amps is a unit. The symbol is often represented by a capital A. Okay, like we just saw there. So where do charges come from? Let's have a look here. So the battery or cell pushes the charges around the circuit. The battery does not produce the charges, they are already there in the wires. So as you can see here, the electrons are already there in the wire. So the electrons are the blue circles with the arrows, and they're moving around. As you can notice, they're moving around in all directions. Okay, they're not just moving in one direction, they're moving around all between the atoms. Okay, the electrons move when you connect the battery, so they're not going to be doing anything until you connect them up. The charged particles are called the electrons there, the blue circles. It would take a long time to draw a picture of each circuit, so diagrams are used instead. So there's no need to be an artist for science, you just need to be able to draw the symbols into a circuit, and there you go. So can you draw this circuit as a symbol diagram? So we've covered everything already in this circuit diagram. In fact, you've already seen this diagram before. I'd like you to have a go at pausing the video and drawing this as a circuit diagram, okay, with the symbols that we covered at the beginning. So hopefully you had a go at doing that. So this is what it should have looked like. So you've got your switch there. The switch is actually open at the moment. It's not closed. So that bulb would not be lighting up right now. We'd have to put the switch down. We've got a battery there, we've got our ammeter represented by the circle with a capital A inside, and then we've got our bulb with a circle with a cross going through it. So we've got everything we need in that circuit to light that bulb. So we've got two diagrams at the bottom here that we've already come across. In these diagrams there are two cells. Cells used together are called a battery. So you've got two cells next to each other. So as you can see in the torch, there are two batteries together. There's two cells, and that makes the battery. A single battery is called a cell. They must be connected the right way or it will not work. So obviously you've got your positive and negative on your batteries. The positive and negative have to be touching for it to work. You can't have a positive and a positive or a negative and a negative. Here's another clip that you can have a look at, okay? This is modelling current. So this is something we might have been able to have a go at in class together, but this is showing that person one, pulls the rope, okay? They're modelling the battery. The movement of the rope is the current. So again, it's showing that movement of the current. Person 2 is holding the rope, is the circuit component. So if you want to have a look at that, you're welcome to, just to try and show it in a different way again. So lastly, we've got some questions, okay? These are from Caboodle that we all often use, and I'd like you, like we would be doing in class, to have a go at completing these. So whether you have a go at definitely number 1 and 2, and if you're feeling really confident and want to challenge yourself, have a go at number 3 as well. So I'm just going to go over it with you first before you pause the video and have a go. So it says copy and complete the sentences below. So whether you want to have a look in the textbook while you're doing this, or if you're confident yourself at having a go without, that's up to you. But if you want to, you need to have a look in Caboodle at the current and circuit page, okay? And that will help you if you read the text and then try and fill in the gaps like it's comprehension. Obviously, number 1 is the easiest because it's got one of the tubes there that shows that it's the easiest, whereas 3 is more of a hard question as it's got the 3 test tubes there. So we've got number 2, draw a circuit diagram to show how you could use a switch to turn a battery powered motor on and off. B, describe what happens in the wires when you close the switch. So draw a circuit first and then describing, so showing your understanding by describing it. And lastly, question 3 is about explaining. So obviously if you're able to explain what's happening, that shows the greatest level of understanding from the lesson. So it says explain how you could use equipment and models to teach a primary school student that the charges do not come from the battery. So that's 6 marks. Obviously that's the hardest question and requires the most detail. So that would be about a paragraph in length, that answer. And that would be if a year 6 came into school when you were asked to explain what's happening in these circuits, that would be what you'd have to do there, okay? So pause the video again and have a go at doing this. This shouldn't take you much longer than 15 minutes or so. Okay, moving on. So it says complete the sentences by linking each half together. So the job of the battery in a circuit is, the job of a buzzer in a circuit is, so the buzzers are what make the noise. The job of the motor in the circuit is, the job of the switch in the circuit is, the job of the bulb in a circuit is. So I'd like you to have a go at this as well, okay? So from the previous questions you've done, again, I'd like you to have a go at emailing your teacher your answers to see how you've got on. So that was if you use Caboodle or if you had a go yourself. So this activity here, I'd like you to email your science teacher your answers. Okay, so I'd like you to pause the video again, have a go at matching up the sentence to the end of the sentence, beginning to the end, and we'll see how you get on. So here's the answers. So the job of a battery, hopefully you put the job of a battery is to provide the energy. The job of a buzzer in a circuit is to transfer energy by sound. because you can hear it. The job of a motor in a circuit is to transfer energy by movement. The job of a switch in a circuit is to turn the circuit on and off. The job of a bulb in a circuit is to transfer energy by light. So, another exercise for you. Again, this is something that we've already really covered, so it really won't take you long at all. Can you draw a circuit diagram from the torch example below, or a handheld fan, for example, with the circuit symbols? So that's the end of the lesson for today. If we were in class, obviously you'd be asked to tell me whether you thought you achieved your LO. So you'd put a tick. Whether you didn't really understand it, it'd be a cross. If you're not sure, a question mark. Hopefully, by looking over any more of the clips that I've put in this PowerPoint, and by emailing your work to your teacher, you'll get some feedback and you can see how you've got on. Thank you very much.